Okay, hello everyone. My name is Mauricio Velasco and I'm here with my colleague Babin Patel. We're part of the Splunk research team, and in today's session, we're going to be talking over about detecting cloud account takeover attacks. So let's go ahead and start. And before we go into the simulations and detections, we're gonna go over some high-level concepts. What is account takeover? Well, account takeover is an attack whereby cyber criminals gain unauthorized access to online accounts by using different techniques like password spraying, credential stuffing, phishing, and spear phishing, etc. So basically, it's an attack where we take control of an account, um, part of a platform. In this case, we're focusing on cloud providers. Now, why should you care about account takeover attacks? Well, it's not news that companies are aggressively moving workloads to the cloud, right? I leave you here with a couple of statistics, but I think we all know this. And the important thing is, just as attackers realize that companies are moving workloads and are relying on cloud, they're also shifting their focus and executing a lot of attacks against the cloud, right? And particularly around account takeover, we've seen a trend of attacks. For example, the Lapsus group. This group has successfully performed breaches without really using the common techniques that we are familiar with, like lateral movement and privilege escalation, specifically, on endpoint-based attacks. No, they're focusing really on identity attacks and taking over accounts that allow them to get more and more access to an organization. For example, a good example of this is the Uber breach, right? So we think it's really important for security teams to be ingesting and have good visibility into cloud authentication and cloud account management, etc. Which is why we wrote 3 analytic stories. Each of one of these analytic stories cover specific cloud providers. Right now, we have detections, specifically 27 detection opportunities across AWS, Google, and Azure. So we think that these detections can help security teams to detect behavior that could be related to account takeover attacks. So with that, we're going to move to the demo. And the first demo that I'm going to be taking over is we're going to be simulating and detecting a few attacks against Azure Active Directory. Okay, so we're going to be going over password spraying attacks, MFA fatigue. So we're going to see that better in the demo. Okay, so first of all, I have an Azure tenant here with a few hundred users ready for testing, and this environment is actively sending events to Splunk. Here's the analytics story for Azure. You can take a look at it online on our website, research.splunk.com. And this has a few detections, but we're only going to be showing 4 of them, okay? All right, so let's move on to our attacker. So here's an attacker computer, and we're going to be using the invoke MSOL spray PowerShell script written by DavHack. And this is a script that allows you to perform password spraying attacks against Azure Active Directory or Office 365. So we also have a list of users, and I think we have 30 or 30 something users here that we're going to spray with one password. And we're going to be using this command that takes this list of users and sprays all of them with this commonly used password. So let's see how that runs. And we're going to be executing the attack against these 35 users. And as we can see here, we found one successful authentication on user 20 that does not require 2-factor. And user 30, we have the right password, but the script indicates that this user requires MFA. So this is something interesting. So with this in hand, what the attacker can do is use PowerShell to authenticate to the environment. And I think it was user 20. Splunk Research. And then now the attacker can start interacting with Azure. So for example, they can Azure get a Azure AD user and get a list of all the users, right? So the attacker has compromised an account and is listing users, and we're not going to show more, but this is just one example. Okay. Now we're going to disconnect, and the second attack, the second user that we had access to, this one requires MFA. So we're going to be executing an attack that was part of the Uber breach, and that is the MFA fatigue attack. So in the Uber attack in the attack against Uber, what the attackers did is they had an account, and they had the password for the account, but they had MFA and they didn't have the second factor. So what they did is they just kept sending MFA push notifications to the user until the user just accepted one, right? So we're going to be doing that here, and then we're going to be sending this user 30 MFA push notifications. I'm actually getting them right now on my phone. So I'm going to simulate doing this, a few times, and then we're going to come back to the video. So I'm going to stop and just do this manually. So I went ahead and performed, I think 3 to 5 MFA push notifications to the user, and they were all denied. So we're going to see on the logs. So as the data comes in, it's going to take a little bit for the data to come in. This takes maybe 3 to 5 minutes. But as the data comes in, let's talk about the detections that we're going to go over. So we're going to be on the first detection, we're going to have multiple users failing to authenticate. So we're going to use Splunk and use Azure AD events to detect one IP address failing to authenticate with more than 20 users in a 5-minute or 10-minute time span. This is a good sign of a password spraying attack. On the second detection that we're going to be showing, we're going to detect two things. Success single-factor authentication. This could be interesting because in the cloud world, we want to, as much as possible, have accounts that always have MFA. Now, that may not be always possible, but we should have certain accounts, maybe administrator accounts. Those accounts will always have MFA. So it makes sense. It's interesting for a security team to detect when an account has successfully logged in using only one factor. That could be a misconfiguration, that could be a policy violation, or that could be an attacker that has disabled MFA. On the second detection, we're going to be showing successful PowerShell authentication. Azure Active Directory allows you to interact with it through the portal, through the API, also through PowerShell modules. So it's not normal for a non-technical user to connect to Azure AD using PowerShell. Maybe administrators, maybe IT, but someone in human HR is not going to connect to Azure AD with PowerShell. So that's also an interesting observation, a detection that we have written that may allow you to detect account compromise. And finally, the last detection that we're going to be showing today is multiple failed MFA requests. So we're using the Azure AD events here to count the number of MFA prompts sent to one user, and based on that, set up a threshold. Perhaps, maybe 10 MFA prompts in less than 5 minutes. That's a detection. So we're going to show those events now here in my Splunk instance. But again, those events take a little bit to come in. So I'm going to wait a few, pause the video here a little bit. Actually, the data is coming in. So let me refresh this. And as we can see here, this is the first detection. So at this time, this IP address failed to authenticate with 33 unique accounts. And these are all the accounts. So this is a good detection to have to detect password spraying attacks. And then on the next one, we see successful single-factor authentication, and we can see how user 20 successfully logged in from this IP address, and this user does not have MFA. So that could be, again, an interesting detection for security teams. And finally, successful PowerShell authentication. Once we found the password, as you remember, we authenticated, and we can see here that this event made it. So the events for the MFA are not yet here. So I'm going to pause just a minute, so let them come in. Okay, a couple of minutes later, the events are in. So if we refresh this, we can see on the last detection here that for this user 30, there were 7 prompts and 7 MFA prompts within 5 minutes, and they were all denied. So once again, this is an interesting observation for security teams to understand perhaps an attacker has control of an account and they're trying to execute the so-called MFA fatigue attack against the user, waiting for the user to approve one of these. So this is an interesting detection. So this wraps up the simulations and demos for Azure, and Babin is gonna take over and talk about AWS. So go ahead, Babin.
Thank you, Mauricio. And hello, everyone. My name is Bhavin Patel, and I'm here to talk a little bit about account takeover attacks in AWS. For this release, I only focused on identity and access management related datasets. And in this demo, I will show 3 different attacks, namely password spray, disabling MFA, and retrieving EC2 password data using Atomic Red Team and various other tools. And I will also show how to detect these kind of attacks in Splunk environments. In order to simulate, run invoke atomic test command again, give it a path to the folder where this atomic lives, and simply mention the test number, which is 9 in this case. You hit enter, and it essentially goes ahead and password sprays a bunch of users with a list of common passwords used. When you're done with this, Atomic Red Team will give you a clear indication that the test is done, and you can do the cleanup of the environment in case any tools are dropped on the server side. After the simulation is done, let's head over to the Splunk server where we are capturing all the CloudTrail datasets created by this activity. CloudTrail is a service provided by AWS which records all different API activities and interactions done with the AWS console, which is a very powerful way of looking for threat actors in your environment and finding other misconfigurations to help secure your environment. In this case, we're going to use CloudTrail dataset again. We're going to specifically look at event name console login, where action is failure. Using this Splunk search logics, we create buckets of 10 minutes of time, and we calculate the distinct number of usernames which have failed to authenticate from a single source IP. Once the number goes above 30, we will flag that event as a password spray attack. And this is essentially how you can go ahead and find various adversaries trying to console spray your AWS environment. Now on to our next use case, AWS multi-factor authentication disabled. This analytic identifies an attempt to disable multi-factor authentication for an IAM user, where an adversary who has already obtained access to an AWS environment can disable multi-factor authentication as a way to plant a backdoor and maintain persistence using a valid account. Quickly going on to the Splunk server, we in order to disable this, we didn't have a very good way of simulating this using a tool. So we essentially used the web GUI console and manually went ahead and disabled and deactivated virtual devices or MFA devices for the root user. So if you want to detect this kind of activity, we recommend that you use event name is delete virtual MFA device or event name deactivate MFA device. We recommend the users to then go ahead and investigate this activity. Now on to our final demo, which is AWS credential access using get password data API call. Attackers can make this API call to your AWS account to retrieve passwords, administrator passwords for Windows instances. These passwords are encrypted using the key pair that you have specified during the launch of the instance, and if these keys are compromised, all Windows machines running on your AWS environments, password can be decrypted and the attacker can gain admin access to those Windows instances. This atomic is a little different than the previous one, and we will be using a tool called Stratus Red Team developed by Datadog. Stratus Red Team, think about it as an atomic red team for the cloud environments, which uses Terraform and other modules at the back to stand up an infrastructure, simulate an attack against it, and essentially giving you the ability to analyze the logs. In this atomic, we will be using an ID called T1552, which is for unsecured credentials. So these credentials are stored on the EC2 instance, and you can make a API call get password data for that instances, and it will retrieve that data set for you. Just like the last time, we will do a show details brief just to check what kind of atomics are available in this YAML file. And essentially, if you look at it, it's there is about one test for it, and this test, which is retrieve EC2 password data using Stratus, is the only atomic which we can run. So let's take the test number or make a note of it and plug it into an invoke atomic test PowerShell command, which first, in this case, we essentially get the prereqs. So download the file from this from Stratus onto your disk. Once the prereq is satisfied, you already have Stratus in your environment, and then you can essentially simulate the attack needed. So the prereqs are met at this point, and we run invoke atomic test command again with just the test number to straight up go and run Stratus, which is essentially going to, if you look at it, it's gonna try and see if it's authenticating correctly against AWS, and then it's gonna run get password data API call against 30 random instant IDs just to see how the simulation or the logs look like in CloudTrail. Just like before, once the simulation is finished, we head over to a Splunk server where we are collecting these CloudTrail logs, and let's analyze it. In this particular case, we are looking for an event name called get password data coming from an event source of ec2.amazonaws.com, and the detection logic is as follows. We bucketize or create windows of time of 5 minutes and check how many distinct instant IDs were requested for get password data. Now, if more than 10 number of if more than 10 number of events are found, then we essentially flag this as an incident, and we recommend our users now that the simulation is done, let's look at the Splunk logs again. Again, like before, we're going to use CloudTrail logs, but in this case, we're going to use specifically an event name called get password data. The detection logic is fairly simple. It looks for distinct number of IDs being requested for password get password data from a singular source IP where the number of IDs are more than 10. So if you find 10 IDs in your environment, which is the threshold we use right now, but we can keep you guys have to tune it according to your environment. But essentially, at the end of the day, you'd get a pretty neat output of like how many instance IDs were requested for a particular AWS account ID from a source IP address, where in this case the client operation was unauthorized, but if it's authorized, you should certainly take a look at it. And that's essentially how we encourage our users to go take a look at these detections for cloud account takeover. Just as a side note, we have simulated an exact same set of scenarios for Google Cloud Platform and Google Workspace datasets. We don't have a demo for that yet, but I highly recommend you guys take a look at all these resources which I mentioned here. And our security content is open source. The tools which we used to simulate these attacks are open source. We are maintainers of Atomic Red Team in our threat research team, And we 100% encourage our users to go to join security research on Splunk user groups and reach out to us if you have any questions or if you need a deep dive in any of these kind of simulations or the new way of thinking about cloud-based attacks. And with that, thank you. I am hoping that this was helpful.